Rising spark, illuminate digital nights. Yes, yes, yes. Tech Titan startups.
Good morning, ladies and gentlemen. Welcome to the 2024 COMPUTEX Forum organized by the Taiwan External Trade Development Council, TITRA. I'm your MC for today. My name is Jeannie Chang. At the beginning of the forum, let us invite Mr. Simon Wang, the President and CEO of TITRA, the organizer of the COMPUTEX Forum, to deliver the opening remarks. Please give a warm welcome to Simon.
Good morning, ladies and gentlemen. Welcome to COMPUTEX Forum 2024, where AI and innovation take center stage. We are ushering in a great time in history where innovation leads the charge, and AI, with its infinite potentials, powers this wave of innovation and revolutionizes industries across the globe. Themed with "Let's talk about Gen AI" at COMPUTEX Forum 2024. We have invited some distinguished speakers lined out of technology frontrunners, such as NVIDIA, Google, AWS, SYNOPSYS, and so on and so forth, to touch upon topics ranging from semiconductor design to cloud infrastructure. Please know that all of us are not just spectators. We are here as active participants to experience a journey in shaping the path of technological progress. Ladies and gentlemen, as we are embarking on this exhilarating journey, I'd like to invite each one of you here in this room to immerse yourselves in the experience, to engage, to connect, and to get inspired. May our time together be filled with discovery and boundless spirit of collaborations. Welcome to 2024 COMPUTEX Forum. Thank you.
Thank you, Simon, for the warm and exciting remarks. Now, let us dive into our innovative journey by welcoming the first speaker of the COMPUTEX Forum, Mr. Mark Hamilton, Vice President of Solutions Architecture and Engineering at NVIDIA. He will share how NVIDIA specialists help you get started with Gen AI at any scale. Welcome, Mr. Hamilton.
Welcome, everyone. It's my great privilege to be kicking off the COMPUTEX Forum this morning. Last week, one of my engineers was showing me a computer-generated, AI-generated news post on a social media site, and it said, "Mark Hamilton, the famous actor, will be kicking off COMPUTEX Forum talking about AI." And the post went on to say even what movies I had starred in. I can assure you, I am not a famous actor. I actually work for NVIDIA, and I help our customers and our partners build the AI factories that Jensen has been talking about. Those of you who know NVIDIA and know NVIDIA culture will know that we like to do, we don't like to talk. And so we talk quickly and we talk concisely, and we explain in simple terms what we do. So one day, several months ago, Jensen wrote a very short email, and he said, "Mark, what your team does is IBTG, Infra, Build, Train, Go." IBTG, and we use this now at NVIDIA. An AI factory is about the infrastructure. The infrastructure is, of course, not just many boxes of GPUs. The infrastructure has to be built. We need all of our ecosystem partners to help us build that infrastructure, and then it needs to be assembled into an AI factory. And why? As soon as you assemble it, you want to start training models. And after you train the models, you go. You run the models. You run your business. You start making money. So let's go ahead and get started. And I'll talk a little bit about how my team works with our partners, works with the ecosystem to help IBTG. These observations are not from PowerPoint slides or studies. This comes from installing hundreds of thousands of GPUs in AI factories. Our first AI factory at NVIDIA was built 8 years ago, 2016. My team and other engineers at NVIDIA started to build our first AI factory. We had just introduced at COMPUTEX the P100, the NVIDIA P100 GPU. I'll show some compares of how we've gone in 8 years. But we've also learned many, many things in those 8 years about installing these systems. An AI factory is not regular data center or regular cloud. It is AI computing. And AI computing is not just about the GPU or adding the GPU to the server. An AI factory is an end-to-end solution. It is nearly impossible to simply build one part of the factory. If you only build a GPU, if you only build some software, if you only build part of the network, it's impossible to think through how you optimize from end to end. And it is, in fact, because NVIDIA for 8 years has been building our own AI factories for our engineers to use. If you listen to the keynote or read it all about NVIDIA, you know how we don't just sell AI factory, we don't just build AI factory, but we use AI factory. We build robotic software, we build AI software for autonomous vehicles, we build AI into our platforms for PC gaming and computer gaming that so many enthusiasts across Taipei, across Taiwan love. What are some of the lessons? How do I measure my team when they build hundreds of thousands of GPUs into hundreds of AI factories? We've actually come up with 3 very simple metrics. This is one of the things I love about NVIDIA. We take something very complicated, building the world's most complex AI factory to train Llama 3, Mistral, other leading open source models, and we condense or summarize into 3 things. The first, and I measure this for every AI factory I build, is time to first train. Because if you're lucky enough to receive 1,000 or 10,000 GPUs, be it an end user, a cloud provider, another partner, you want to be able to quickly as possible start training your models. You want to train your model so that you can be ahead of your competition, so that you can use the model to start running your business. Traditional supercomputers have often taken 6 months, 12 months, 18 months to set up. There has been for many decades a list of the world's top 500 fastest supercomputers. And many of these, of course, can run AI today if they are accelerated and be used. But these supercomputers were built by large national labs, by large universities, where they had many PhD students, many researchers that had their job was to build supercomputers. As AI factories move into the cloud, move into regular enterprises, we can't build every one of them differently, like the top 500 supercomputers. We need a recipe so that we can deploy them quickly. The GPU is simply too precious a resource to be deployed and sit in your data center while you try to assemble it. So time to first train. AI supercomputers actually are very good at traditional science as well. In fact, many of them end up being put on the top 500 supercomputer list. There's a pharmaceutical company in the United States, Recursion Pharmaceutical, and several months ago, they ordered one of our DGX SuperPod AI factories, and they waited a little bit too long. And so they were going to miss the deadline for the top 500 list in June. So they came to us and said, how quickly can you install it? It was 512 GPUs, relatively small by the scale of systems today, but still relatively complex. That many GPUs, you might take months traditionally to set up. And the top 500 deadline, by the time they received their systems, was 1 week away, 5 days away. We were able to install their system in 1 week, run the top 500 benchmark, and get it on the top 50 of the top 500 supercomputers. And it's there today. You can go look at top500.org and see Recursion Pharmaceutical. So time to first train. Second is GPU availability. Now you might say this is a funny metric. 100% of the GPUs should be available. Now remember, Jensen talked about our latest GPU, the GB200 NVLink 72. One rack, 600,000 components in that rack. And now many of those racks, millions of components in an AI factory. If you wait for every single one of those millions of components to be perfectly running, you will always be waiting. The software working together with the hardware has to work around failures in the system, be resilient to failures, and continue to train the model. Because these large models, a trillion parameter model, may use tens of thousands of GPUs, many racks of GB200 for many weeks, maybe many months. Impossible to keep all the equipment going. So what is your availability at the time to first train? And finally, what is the time to train? To measure how good a job we did putting together the cluster and measure how good a job the OEM and our other partners did to make sure they followed our recipe, we compare against our internal supercomputer that is our reference. And I'll talk about some of our internal supercomputers. We get a time to train. We run this test for about 6 hours. It can be run shorter or longer, depending on your needs. The test runs NVIDIA's own Megatron open source LLM. Many people have maybe never heard about Megatron, certainly not as common as GPT or Llama or even Mistral, some of the other models. But because Megatron is open source, it's an open reference. Any OEM, any customer can get that benchmark, run it on their system, run it on their cloud, and compare how good it is. And so for 250,000 GPUs that my team installs every few months, simply 3 numbers: time to first train, GPU availability, and time to train. And with those 3 numbers, which we know for every size cluster, 1,000, 10,000, 20,000, and for every OEM, we can compare and judge how well we're doing. And why is that so important? It's of course so important because of the advances in generative AI that you're all hearing about. Now, ChatGPT did a great thing. NVIDIA and many other companies had, of course, been working on generative AI for many years. But it was researchers, it was in the lab, maybe some data scientists. The average CEO, the children and the parents of the average CEO had never heard of generative AI and large language models. And then in November of 2022, OpenAI released ChatGPT. And now not only every CEO, but the CEO's children or grandchildren and parents or grandparents for the younger CEOs, all of a sudden could see the power of Gen AI. But of course, and it's funny to talk about ChatGPT as that early or first generation of generative AI, was relatively simple compared to what's being done today. It was simply text, chat. Type in, type a few hundred words, get a few thousand words back. But now think about all the ways that we're learning to use generative AI. Generative AI is, of course, multimodal. It could be text in, it could be audio in, it could be an image in any of those out. Think 100 words in, many images out. 100 words in, a multi-gigabyte video out. And then, as Gen AI applications are connected together with agents, you have one Gen AI application calling another, and interacting, and then bringing you back a story, operating a robot in a factory, showing a car how to drive down the street, automating many other tasks. So how does NVIDIA help customers move forward and get started? Beyond simply building Gen AI factories. If we were to come in and build a Gen AI factory, or if you were to rent a Gen AI factory from your favorite cloud provider, and all of the cloud providers work with NVIDIA and follow our blueprint for putting together these Gen AI factories, then what do you do with it? Well, NVIDIA Inference Microservices, or NIMs, a very short word, easy to pronounce, N-I-M, NIM. What is a NIM? Well, the challenge with the good thing about Gen AI is that so much of it is done in the open source. You have, of course, proprietary models owned by companies. Not that proprietary is bad. Gen AI or ChatGPT, Gemini, other proprietary models. And then you have fully open source models. In the open source community, everyone can see, as the code develops, as the models are released, can take advantage of those improvements in the model, and other researchers can improve on top of that. And of course, companies will continue to develop their own models, proprietary, and then when they're ready, release amazing new features for you to use and through APIs for their partners to use. But as a data scientist, as a developer in an enterprise, how do you get started with Gen AI, with all these open source models? A very good analogy is perhaps 20 years ago in the early days of Linux. Linux has, of course, open source versions. The fact that the Linux kernel is open means that different companies around the world can go in and build Linux operating systems, add their value, and distribute them. Red Hat Red Hat Enterprise Linux, perhaps one of the best known enterprise distributions of Linux. And so what NVIDIA felt the world needed was not another Gen AI model. NVIDIA, of course, has our own models under the Megatron name. Some are closed, some are open. There's great models out today, and there's many open source models. So we'll continue to develop our models when there's a need. But the open source models are so good, but we needed an operating system for AI. Just like as an enterprise, when you started using Linux, you went to an operating system provider to get an enterprise copy of Linux. Where does an enterprise go to get an enterprise copy of everything you need to build and to run AI? So that is NVIDIA AI Enterprise, our AI operating system, and our NVIDIA Inference microservices. A microservice is, of course, means that you do not need to install the entire operating system. You can install the entire operating system in your data center and run a microservice on top of it using our APIs, or you can simply call an NVIDIA Inference microservice that is running in any of the clouds. So again, what then, besides what is at the core of an NVIDIA Inference microservice? We take all of the leading open source models, Llama 3, Mistral, on and on, our own models, and we optimize them for our GPUs. Not just for one GPU, but for all of our GPUs. The A100, which is still in many clouds, the H100, in the B100, and of course, thinking today about how do we optimize models in the future for our new Vera Rubin GPUs coming out in 2026. Only NVIDIA could be thinking today about how we optimize AI software for a chip that is not even built yet. So what's the result when we put the two of these together? These are some of the internal supercomputers that NVIDIA has built. I mentioned that our first supercomputer was built back in 2016. It was called Saturn V. At the time, like the Saturn V rocket from NASA, we thought it was a very big supercomputer. It turned out being the 30th fastest supercomputer in the top 500 list at the time. There was no measure back in 2016 of how fast an AI factory or AI supercomputer is. Today, of course, there's the MLPerf set of benchmarks. And these supercomputers that you see here have been year after year #1 in performance on MLPerf. And in a sense, that's not very surprising. NVIDIA builds the chips. We build much of the software that's inside the large language model. We build entire supercomputers. So of course it makes sense that we should be able to optimize and be among the fastest in the world. So our new super chip is called Blackwell, and we've heard a lot about it in the last several months, so I won't go in and repeat too much here. But again, it includes many components built by our partners. The chip itself is, of course, fabricated by TSMC. We work very closely with TSMC on the 4N process for the transistors. And again, as great as TSMC is, we take all of their tools, all of their knowledge. Our engineers sit together here in Taiwan and across the world, and we figure out how to make the process even better for Blackwell in future chips. It uses fast HBM memory from the 3 leading HBM memory providers. I believe Micron is talking later today, which is one of our partners for HBM. And what's the result when we put Blackwell together with all of our experience building AI factories? Well, again, this is looking at it in several different levels. In the first is you'll say, well, Mark, you know, NVIDIA's chips keep on getting more expensive. And that's true if you look at the price of an individual chip. In fact, for $1 billion back in 2016, you could have bought about 45,000 chips. And today, you can only buy about 11,000 chips. But look at the performance improvements that you get. The GPU performance, the time it takes to train a model, and the amount of power you use to run the model is all drastically reduced. So again, continuing to look at energy efficiency and to look at performance and price performance, i.e. value, in delivering the best solutions. Our building blocks today for the AI factory of the future are around the GB200 NVLink 72. As these systems get more complex, we have, again, so many great partners here in Taiwan that are building these individual parts, taking the NVLink switch tray, taking the compute tray, taking the superchip module, and building it into servers. As I said, it's not just about the server. It's understanding how all the connections work and how this works all the way out to the software. Thinking about just one component, NVLink. There's been a lot of discussion about NVLink the last few days. NVLink is not just a wire connecting two GPUs. NVLink, now in its 5th generation, is the entire end-to-end system for connecting the 72 GPUs in the rack. Jensen showed the large wiring connector, 6 feet tall, the ability to send a signal out of one GPU through a set of NV switches, through 6 feet of copper, out to another GPU. NVLink, in a sense, starts with software inside the GPU that initiates the communication, goes through the entire set of switches and cables, comes out the other end, and makes those two GPUs, those 72 GPUs, act like one giant GPU. Now, building the AI factory is a lot more than just putting the servers in the rack. In fact, the rack comes pre-built in the factory. 2 miles of copper cables in the back of the rack. It weighs several thousand kilograms. You have tens of gallons of cooling liquid per minute flowing through the rack all the way to the GPUs. And it consumes 120 kilowatts of power. What it saves is thousands of kilowatts of power compared to older GPUs. Again, this system will cost millions of dollars, will start being deployed soon this year, and we're already in the process of planning very large data centers around the world for our partners, very large AI factories that will be deployed in every large cloud, in many regional clouds, and in private data centers by private companies. So, if you're not quite ready for this 72 GPU rack, we of course have smaller ways to get started. One of the new products we announced here this week at COMPUTEX was the GB200 NVLink 2. It's an industry standard MGX server that fits in any standard rack, and it puts together 2 of the GB200 superchip modules connected by NVLink. Very easy to deploy, very easy to scale out, and ideal for inference. Remember, as Jensen has said, training the AI model, that can be done anywhere, subject to constraints of where your data is. AI doesn't care where it goes to school. You don't always have to train your models in the city or the country or the data center. You can move that training to places where energy is less costly and more available. But then when you run your model, you want to run your model as close as possible to where the activity is. So this GB200 NVLink 2 being able to fit in a standard server in any data center of the world is super important. Now, going the other way to build an entire data factory, one rack of NVLink 72 will not be enough. You, of course, read every day on how companies are using thousands or tens of thousands of GPUs to build AI models. So, how do you connect together multiple of these racks? Again, this is very different than normal data center or normal cloud, where you would simply take your racks of web servers or database servers and connect them together with regular networking. An AI factory is, of course, not regular compute, it's accelerated compute. So the DGX SuperPod with DGX GB200 systems is a blueprint on how you can build an AI factory. This particular blueprint scales up to 576 GPUs in one scalable unit, and then you can then put multiple scalable units together. With the 576 GPU building block, you can go up to 9,000 GPUs. Now, of course, as I said, you've heard of customers using more than 9,000 GPUs today. So we continue to scale up. You can put together, using a building block of 1,152 GPUs, you can build up to 18,000 GPUs. So this will be one of our standard AI factories, deploying up to 18,000 GPUs. And to anyone in the audience that would like to build an AI factory of more than 18,000 GPUs, don't worry. Please come talk to your NVIDIA representative or to your OEM partner, and we have designs to scale beyond this as well. And finally, while many people are used to InfiniBand networking, which Jensen showed continuing on our roadmap, for people who absolutely want to or would like to use Ethernet, we can now build AI factories with our Spectrum Ethernet. So I'd like to thank everyone for being here today. Thank all of our partners that make the NVIDIA AI factories possible. We cannot build any of the AI factories. We cannot IBTG without these partners. So thank you very much.
Thank you, Mr. Hamilton, for your inspiring presentation. Up next, we have Mr. Thomas Anderson, the Vice President of AI and Machine Learning at SYNOPSYS. He will provide an overview of recent AI trends and share insights on how generative AI technology can be applied to optimize and automate chip design tasks. Welcome, Mr. Anderson. The floor is yours.
Okay. All right. Thank you. It's an honor being here. This is the first time that SYNOPSYS is presenting at COMPUTEX. I was intently listening to my previous presenter from Google, and I have to out myself. I'm an Android user. Not just that, I have a Pixel phone. I'm a happy user of it. And we're going to talk about something very different today. We're going to talk about the software that's being used to build the chip inside those phones and many other devices. So that's what SYNOPSYS does. Our motto is silicon to software, And we essentially built electronic design automation software that helps you design those super complex chips in there. And for us, we're using AI to design those chips. And the funny thing is, you're using AI chips, you're using AI software to design AI chips. So it's kind of like a self-fulfilling prophecy. You should also know, just like the first speaker today, I'm also a famous actor. If you look at my name, maybe anybody remembers The Matrix, Neo, Thomas Anderson. But they replaced me with AI now, so therefore I changed my job and I'm working at SYNOPSYS now. All right, so over the past years, I think we've seen a reinvention of computing. It used to be all focused on CPU and pushing the frequencies and adding more cores, and now we have AI accelerators. We have GPUs, of course, and as a result of that, an explosion of intelligent systems. I would say, again, reference to my previous speaker, the most useful thing, this is a very cool presentation from Google, the most useful thing to me was asking the system where my glasses were. Because I check, where did I put my keys? So if I have a system that tells me where I put my keys, oh, you forgot it in the refrigerator next to the eggs. That would be very, very useful. All right, so let's take a look a little bit at some of the trends that we have. The first one, I think, is obvious. So in the generative AI space, I think we can expect that many design jobs, like mobile web applications, for example, will be automated. So here's an estimate. In the next 5 years, we expect that 70% of the web or mobile applications will be done more or less automatically, which makes sense if you think about it, because there's a lot of, I would say, repetitive stuff or building blocks that can be reused. And as a result of that, and many, many other things, of course, we expect by 2028 a huge increase in workloads at AI and data center. And that, of course, is also driving this AI chip boost, essentially. So let's take a look at some of the data that's been generated over the years. And you can see here there's sort of an inflection point. You see at the very bottom, like this orange-yellow piece, it's hard to see because it's so small, is human-generated data. So these are things that you're typing, that you're writing, that you're drawing. And up until, say, 2018, this was still dominating. And you can see now that since then, machine-generated data is taking over. And in fact, you see an exponential growth. And if you also look at this graph, you see sort of a breakdown. You think, well, most of the data generated is maybe social media. But that's not true. There's a lot of industrial data that can be used to essentially optimize processes. There's home IoT solutions like Alexa and Google and things like that. And there's also, you can see a big part there, automotive. When people think AI, they oftentimes think about self-driving cars. And there you can, of course, log millions of miles and generate a lot of data and hopefully learn from them to be better than a human. We're not there yet, but hopefully we will be. And new AI models, if you look at this graph here, you can see they're pushing the limits of compute. In fact, you sort of see another inflection point. You see where with transformer models, the required compute is increasing about 275x over 2 years. And if it's exponential, of course, that number will go up more. And you can see here, this isn't even showing the latest one. This is still GPT-3. And as a result of that, it puts huge constraints onto computer chips and the demands for building those. So at the heart of all this are essentially what we call AI superchips. I have a few examples here. I know we've seen a lot of NVIDIA examples. We've seen announcement from AMD, from Intel, from Qualcomm at COMPUTEX this week. Here's two very, very super large examples. One of them is a Cerebrus wafer scaling engine. So you can see There's a lot of repeated structures in there because these are essentially thousands of repeated cores. And they're used, for example, for specialized applications in medical research, things like cancer research, even COVID-19 research. They use these types of AI superchips. Another example is from Graphcore. That's a European company that also has these super, super large chips. In fact, I've seen a picture when you hold them up. It's about this size. It's incredibly large. So that you have that on one end. On the other end, you have the edge IP. So things like on your mobile devices or in a drone. And they obviously need to be extremely small. And the power consumption needs to be extremely low. And in both of these different types of spectrums, so one is all super high performance. The other one is essentially medium small performance, but very, very power optimized. For all of these, you need to design specialized chips, and you need the software to do that. Now, if you look at chip design, many people that are not familiar with this, and maybe they come from the software world, they're astonished how long it takes to build a chip. It's not like you writing software and in a few months you have it and you compile and out you go. There is many, many complex steps involved. There's many, many iterative loops like architectural design, structural design, logic design, ultimately layout design, so that's the physical representation, that then gets sent to, for example, TSMC or Samsung foundries to actually put it on a wafer and make sure it works. Make sure it works functionally, it meets performance requirements, the yield is acceptable, because otherwise it's cost prohibitive. So as a result of that, typically tens to hundreds or maybe even thousands in some cases engineers are spending their time building and optimizing these chips, and it takes upwards of 2 years in some cases to build a new chip. And the beginning of electronic design automation software, which essentially replaced doing manual design, like drawing logic or even transistors level in the analog world, replacing them with automated tools, started in the late 80s. And since then, we estimate we've done something in the range of 10 to the power of 7 in design productivity, which means today, instead of having tiny little chips with a few hundred logic gates, you essentially have many, many millions of logic gates on a chip, and you can still do that in a reasonable amount of time. So that's obviously a very, very big challenge. On top of that, and again, driven by these exponential curves that you see here, there is an ever-increasing complexity in the size of the chips. And we only have limited amount of people. There is a projection that you see here in the middle from, I think, Boston Consulting Group that estimates a 30% talent shortage by 2030 in terms of designers needed to build those chips. So how do you overcome this? I think the only way to overcome this is using artificial intelligence to essentially automate some of the tasks that are humans doing today. And we're starting, I would say, with more mundane tasks, because we don't want to take away the creativity and the brains that the humans have. In my opinion, at this moment in time, and I can't say in the further out future, but at this moment in time, there's no AI system that possesses the creativity of a human being. However, there's many, many useful applications where, like similarly to what was shown in the Google slides, where you can automate certain tasks, like composing emails, summarizing things. The same thing applies to our world. There's many, many tasks in chip design where people don't actually want to do that because they're boring. You want to have a system that looks through log files of your runs and figure out what to do next, and optimizing for performance through tweaking parameters in your system. For these kind of things, I think AI applications are very useful and also very welcomed by humans because they do a task that is kind of boring. So that's sort of the catalyst for AI design. And I mentioned in the beginning, the funny thing is that we're building AI software to build AI chips, and then they run on AI chips to build the next level chips. So it's actually a very interesting loop and sort of a self-fulfilling prophecy. So let's take a look a little bit about what's different in our world. So we're not Google or Facebook who can collect essentially millions of images like this. You can look at it. Is this a chihuahua or is it a muffin? We actually have this joke in EDA that we deal with images that are not cats or dogs, but other things, right? So anyway, it's very obvious if I train a system with millions of examples, even though you have to look closely to figure out which one is a dog and which one is a muffin, I think easily, of course, the system can figure that out with enough training data. Similarly, let's talk about self-driving cars. If I log millions of miles and I essentially have every possible scenario that I encounter, I ultimately should be able to outperform a human, because how many human drivers have seen all possible scenarios? Most of the time you drive around, you have theoretical examples of what would happen if, say, a kid runs in front of you, or like a particular scenario where maybe somebody breaks and you need to do an emergency evasion maneuver. People go to driving school for that, to get those specialized skills. If I get all this in the system, I have no doubt that a system could outperform a human and be much safer. But I can train the system with lots and lots of data, because I can just go out in the real world and train it. Unfortunately, in our world, things are a little bit different. Since we're building chips, essentially, there is literally very limited amount of public data. It's typically what universities have. There's open source cores, very log descriptions, and so on. But of course, the cutting edge technology, they're all compartmentalized. And every company, of course, be it NVIDIA, AMD, or Intel, of course, they want to protect their own IP and their own intellectual property. Therefore, they guard their data. And therefore, the only way to train a system is to train it on-prem at essentially the chip maker itself. The other thing that's interesting is we have rapid changes in technology nodes. Like every 18 months, and that's accelerating, you get a new technology node. Like TSMC comes out with 5 nanometer, 3 nanometer, 2 nanometer chips, and every single time things are changing. It's as if you were driving your car, and every 12 months they change the rules of the road. They have different signs, and they say, okay, now you need to yield here, and you don't have to yield there. So you have to constantly adapt. And that makes our job, in comparison, much more difficult. Nonetheless, SYNOPSYS has been the pioneer in AI-driven chip design by essentially offering a number of breakthrough capabilities. We started in 2021 by by introducing what we call design space optimization, or DSO.ai. That's essentially the paradigm of using AI for an optimization tasks. So you have complex tools, and you have workflows around those tools, and you need to meet certain performance requirements: power, area, frequency, of course, because you want your highest performing chips. Traditionally, humans are essentially designing scripts around systems and workflows, and then they optimize them. It's a very tedious process. We developed essentially an AI optimization system using reinforcement learning that can do the same job that a human does, in fact, can do it better. And I'll show you some examples on that. The second thing we have is data analytics capability. I think the most maybe plausible or explainable scenario is when you look at yield, for example. You want to build a chip that has high yield. That means when you produce it, you have very few failures. For this, you need to essentially analyze large amounts of data and find patterns that are causing these failures. For that, we have developed data analytics capabilities and essentially help the human to identify this. And the third thing, and that's of course the big topic today, is generative AI, where we've invested in a number of capabilities, starting from co-pilots to help you run and optimize the tools, all the way to generation of actual inputs. So in this case, it's not emails. It's things like, we call this RTL. That's essentially a hardware language description of how the chip should operate. And you can build systems that help you generate this from a natural language description. But first, let me look at some examples of the AI optimization. So my team actually pioneered this work about 5-6 years ago, and we launched it in 2020. And originally, my goal was I wanted to be as good as a human doing this task manually. Again, this is an iterative task. You essentially run EDA tools many, many times, and you try to tune it to optimize your performance. Originally, I said, okay, we're going to do it faster, but we're not going to do it better. We're just going to get the same results as a human. And then what happened is we actually got better results. And every time when we went to one of our customers, they said, whoa, you actually have a much better result. And after a while, we figured out this is a task that a machine can do better than a human. And here's some examples. So you can take a chip. These are all from big customers. You see them at the bottom, the quoted AMD, Intel, Microsoft, NVIDIA, Renesas, and so on, Samsung. So whether it's shrinking a chip, reducing your die size by 12%, that's a huge cost saving. Reducing the power, of course, is very important for various reasons, not just power consumption itself, but also battery life, of course, heat that's being produced in a data center, and of course, things like frequency. Everybody wants higher performance and faster frequency. So there's many examples where this is actually showing better results than a human could do. So let's take a look at generative AI. And I think generative AI, I think one of the first speakers said it, isn't necessarily new. It has just come, it's gotten popular since we now have large language models. So we now essentially have systems that have been trained with billions of weights, a neural network with billions of weights, that has all the information that's out there. And when it comes to pure knowledge, I mean, it is wrong at times. We've all seen that. We've seen hallucinations. But when it comes to pure knowledge, I think nobody will question that it can beat any human, because none of us has studied and read every single book that's out there and can know exactly what was written on page 254 of a particular book. What is, I think, interesting is that you feed it the right information, because when you tune the system, you have to make sure that actually the answer comes out, essentially processes maybe potentially conflicting information and gives you the proper answer. So let's look at chip design. Generative AI chip design, what could it do, for example? One simple thing would be support assistance, automation of workflows, generation of inputs, like similarly to, say, GitHub Copilot, where I write C++ code and it auto-suggests. In this case, you can build a system that generates RTL. Again, RTL is a hardware description language that describes how a chip should operate. And of course, in general, content creation from some human language spec. If you look back, chips are actually created based on an initial human language spec. So there's documents that describe precisely how the chip should operate, what it should do. Taking those and translating them into actual consumable input for EDA tools is extremely powerful. There's, of course, a number of challenges. The big one for us is things like copyright IP protection. As I mentioned earlier on, a lot of the data that we need is not in a public domain. So it needs to be trained on carefully selected data with the right background. The problem complexity, of course, is also much harder. We're not talking about just self-driving cars or summarizing emails. We're talking about designing chips. So the task here is much more difficult. So late last year, we introduced what we call SYNOPSYS.ai Copilot, and that is the industry's first generative AI-driven EDA stack, and we launched this together with AMD, Microsoft, and Intel. This is essentially the expansion of our AI technology towards generative AI, and it includes what we call collaborative, generative, and autonomous capabilities. And I'll show you a few videos in just a moment that give you a little bit glimpse of what it actually does. In fact, here's the first video coming right up. So this is our SYNOPSYS Copilot. you have essentially a tool where you implement a chip, and you have a Copilot window where you can ask human language questions. Very simple things. How do I set up my tool? How do I, for example, check my timing of my chip to make sure that I don't have violations? You can see there's links to trusted documents in there. We also process multimodal content, and you can see here in just a moment, for example, you will have graphics, you can even have videos that you can look at, and they show you examples of how to do things. Now, if you think about this, ultimately, this becomes the brain of all your information that you have. And some of this information is today in documents, and you just feed it in the system and then it tells you. But a lot of this information is in people's heads, which is why we spend time essentially training our system with expert knowledge. And then, of course, you can ask follow-up questions. You have a chat interface where you say, what about this, what about that, and ask even questions specific to the very design that you're working on. So you may say, okay, well, that's interesting, but that's not all that exciting. It's okay. It's a Copilot. It answers questions. It gives me suggestions on what to do. But I have something much cooler than that. And in fact, I think it was Mark who mentioned about agents. So the next level of LLMs is not just answering questions, but it's an LLM agent system. And that's essentially a capability where I now take an action. So I have an LLM, I give it a memory, I give it a task, and I tell it to execute something. So in this particular case, I have a chip design. It's not meeting my performance requirements, and I simply tell the system, fix it for me. And the system behind the scenes generates essentially a number of tasks. They may even fail. And then the system learns, aha, this didn't work. I'm going to try that instead, until it is actually able to complete the task. So that is extremely powerful. And the way this works is through the same Copilot window, I load up, in this case, a chip design. I have what we call design rule and timing violations. And I simply say, hey, please fix them for me. That's all you have to do. And in the system, you can see it sort of on the left, it executes in the background a number of commands. These are not pre-configured scripts. These are things that, based on the context you were asking, it essentially generated. It gives a little task, it checks on the response. If it doesn't work, it does something else until it is able to fix the problem. And in this particular case, probably hard to see, but you can see here at the very bottom, you started with a design that had violations. It wasn't possible to tape it out. And now I have 0 violations left. So my timing is met. To me, that is incredible, because that is the next level of automation. A system that I actually give a job, and it is able to do it for me. And remember how I said in the beginning, we don't want to take away the creativity from people. So creativity, I think, is still important. But what we want to do is we want to automate typical tasks. So tasks that people maybe have done hundreds of times. And we want to make this power available to all the users. Let's, for the moment, assume you have a company and you have 100 chip designers. Out of those 100 chip designers, 5 are your top experts. If I train my system with their knowledge, then essentially I give the power from those 5 expert users to all hundreds of users. That is the power of generative AI. So these are some early results on the Copilot capabilities that we have, and some of the things that I've demoed with you. You can see here some quotes. So we're seeing something like 30 to 50% productivity improvement. In fact, there's a quote that talks about junior engineers are now operating at the level of expert engineers, and that's exactly what we want. You put the power into everybody's hand, and responses are much faster, of course, than having to ask a person or looking up in some documentation and find an answer there. I also wanted to mention, of course, our work with NVIDIA. I already mentioned that I'm also a famous actor, just like Mark Hamilton, maybe even more famous. But beyond that, we're working closely with NVIDIA on enabling them, of course, to build their chips with our software. In fact, all the announcement that you've seen so far from AMD, from NVIDIA, from Intel, from Qualcomm, they all use Synopsys software to design their chips. So we have a very, very tight relationship. In one of our corporate events, we call this SNUG, this is our user conference, that happened earlier this year. We had Jensen on stage with our CEO, Sassine Ghazi, and Jensen was telling how we were the first company for chip design software that he ever wrote a check to. And now, of course, they're a very, very big and expensive company. They're very successful, and we're very happy that they're still our partner now that they've grown so large and they've become so successful. And we've been essentially working with them on many, many things: verification, design, simulation, manufacturing, including generative AI. And we're, of course, using the NIM service that was mentioned by an earlier presenter. So that's one of the backbones of making sure that our generative AI applications work as effectively as possible on top of NVIDIA GPUs. So, in summary, Synopsys.ai is mission critical in the area of pervasive intelligence, and it's enabling users at every stage of chip design to make big breakthroughs. And we're pioneering the next level of generative AI capabilities. Again, from going things like AI optimization that was inspired by AlphaGo. Remember AlphaGo? AlphaGo is a reinforcement learning system that was able to beat the world champion in Go. And that was a very, very difficult task because unlike chess, which could be cracked with just sheer compute power, I don't know if any of you remembers in the late 90s, the IBM Deep Blue supercomputers that essentially finally beat Garry Kasparov. That was more in terms of using raw compute power. Like, I calculate so many steps ahead, and then at some point I can beat a human. But a human, of course, doesn't work that way. So reinforcement learning in AlphaGo was introduced around 2016. For us, this was the inspiration to build AI optimization for chip design. And that's one of the things I mentioned earlier, showing you the big performance gains that we've had. Since then, we've added, of course, with the introduction of OpenAI, the generative AI capabilities. That is available on OpenAI, but is also, of course, available on many open source models for on-prem installation. And I personally think this will revolutionize the way chips are being built. And that essentially enables building larger and larger chips using the automation of AI. So AI is the only way forward. Thank you very much.
Thank you, Mr. Anderson, for demonstrating the power of chip design in accelerating AI development. For the last session of this morning, we will hear from the enterprise strategist at AWS, Mr. Xia Zhang. He will illustrate how to develop capabilities to harness the potential of generative AI. Let's welcome Mr. Zhang.
Good morning, ladies and gentlemen. My name is Xia Zhang. I'm from AWS. So we heard 3 presentations in the morning. Let's switch the gear and to hear something a little bit different. I'm trying to tell you, in the era of generative AI, how enterprise, and including all the business and IT people, we can take advantage of generative AI and lead the digital innovation. So in the process, I will share also AWS provided cloud-related service to help you to achieve that. So we all know, like people said, beginning from the November of 2022, ChatGPT released, and it offered chatbots, search engine, and it touched everybody's life. So people start to feel the power of generative AI. And then actually, the real power of generative AI is far beyond just search engine and chat box. And we believe actually all the companies, all the industries will be impacted by generative AI in the coming years. And it will change many things, including how we live and how we work. So just for general easy purpose, usually we put the effect of generative AI in 4 large categories. So this is like, change the user experience, provided a new, innovative, and engaging way for people to work. And also, it's widely believed it will change productivity. Actually, Goldman Sachs has a report that says in the next 10 years, generative AI will provide somewhere around 7 trillion incremental GDP growth. And it also says it will provide productivity gains averaging about 1.5% per year. So that's a lot of productivity increment. And also, we believe generative AI will be used widely to provide business insights. So all the data will be analyzed and then will be used to gain about the market, about the product information, about the customer experience. And then the last one actually is something we're not sure yet. So we believe generative AI will give everybody a lot of opportunity to create brand new things. And basically, there may be some new killer apps. We still don't have any idea where it will come from and how it will change our life. So generative AI is a big thing, but actually, like my team, the enterprise strategy team, we consist of formal CIOs from large enterprise worldwide, like my teammate from Coca-Cola, from Capital One, and from many of those companies. And when we engage the customers actually now are all looking into how to use generative AI to help their company to create value. But they run into a lot of problems. And here I give you some of those. For example, like, how to really assessing those multiple foundation models, including how to select them, how to make them customized to fit their own data and the company, how to really, make sure the data will be safe and secure and it will be kept in their own enterprise, not being shared unwillingly by other people. And also how to make sure, it can build into generative AI apps and help you to execute your task. And things like that. So in easy way, customer basically ask a couple of questions. Which model should I use? And how can I move quickly and begin my AI journey? And then how I can keep my data secure and private. Those are some of the fundamentals questions we met. And I believe our friends sitting here today probably have similar questions. So we want to give you a simple, easy 3-step platform, how you can think about those and how you can help your enterprise to begin your AI journey. So the first thing actually is not a technical decision, it's a business decision. So for every company, the first most important thing is you need to work with your company executives, the CEO, the chairman of the board, all the leadership team. You need to decide what business scenarios what business case you need to work on. That will give you the biggest impact and also give you a good return on your investment. So let's take a look, in this area, what kind of thing we can suggest. First, people believe generative AI will basically have very broad impact to every industry, to companies of all sizes, large and small. And here I listed some of those companies, industries. So you can see actually for healthcare industry, there are many things you can do. You can talk about medical imaging, drug discovery. You can talk about how to enhance the clinical trials. And for other industry, media and entertainment, you generate a broadcast content, you optimize your subscriber experience, and so on and so forth. Almost every single industry will be impacted. And here I have a little bit of a quick flip through. Actually, if you look into the details of each industry, you need to identify some particular areas that you believe that will differentiate company in that industry. And here I gave a simple example of Merck, a well-known pharmaceutical international company. And they do very simple things on AWS. For the drug manufacturing process, there are so many steps, so many things you need to consider. And then they gather the manufacturing data and put it into an AI model. And they are doing a very simple thing. They use that data, building a model, and implement that into their manufacturing inspection process. And then they claim actually they can, using that synthetic image with their customized model, they can reduce the so-called false rejects by 50%. So basically, that's something you think the drug is no good, but that's not true. So this way you can see that's almost immediately, that's 50% of money saved. And then, so we can see actually choose the right business case is the most important thing. And our suggestion is for IT leaders, you probably want to select something that's important but not critical. So that's something, when you do it right, your company will be able to get benefit from it, to differentiate yourself with the competition. But at the same time, you don't want immediately to working on something which is super critical for your company, for your cash flow. And because if you do that way, if you do something wrong, the whole company will be in jeopardy, and you will be under spotlight, and you will be endangered your own career. So in that process, you help the company to build up the capability. So the second thing very important is about the data. I think one of our last speakers showed a chart and showing how the data is accumulated and how machine-generated data, starting roughly about 2019, already surpassed what human-generated data. So in this case, actually, generative AI application will be built on the data. And the whole AI situation is like a big iceberg. So only about top 10% is what you see. That will be your generative AI application. But behind the water, there are many more things that's very fundamental for your AI success. And that's all data related. You need to have ways to store your data. You need to have ways to build up analytical capabilities. You need to have ways to interconnect your data. And then you also need to make sure the data is both safe and secure, and also be compliant with data sovereignty-related regulations. So in this case, actually, we do help our customer a lot, and we feel data actually is your key differentiator. And by the way, in the so-called digital times, people are doing digital transformation and digital innovation. The most thing actually for a company to do, which as an IT leader you can do very safely, is working on your data. Because AI or not, working on the data is already one of the key things that will prepare a company for the digital era. But for AWS, we have a so-called modern data strategy and architecture. And some of the key elements is we call it comprehensive. You need to have a comprehensive coverage of all the data. You need to have them integrated, and then you need to have them governed. That means you keep them safe and secure. So you probably know, AWS will provide it from a simple storage service. It's called S3. That's where most of the data being trained and being used by AI is stored these days. And we also offer 8, what we call it, purpose-built databases, including SQL, non-SQL, including time series, many different graphic, many different specially built database. And then actually this data will be used for a couple of things. First, you can use that to do the so-called retrieve augmented generation. Basically, you port some of the foundation model, but you incorporate all your private company data into that, and doing basically AI assistant and AI improved search, so you can use all your data. Secondly, you can take your data, put it in your on-premise or on cloud in a safe environment, and then you can train them and fine-tune them and get your own version of those foundation models. And then the most advanced thing actually is, since you will have additional new data being generated and getting into your system as a function of time, so the most advanced thing is so-called continued training of the data. So data come in, and then you do both RAG fine-tuning and continued pre-training, and data undoubtedly will play a very important role. So when you do it right, then data of all different kinds, both from the public domain and from your own private company data, will come in, and then those will be used to either do retrieve augmented generation or fine-tuning a foundation model or continued training of your model. And then those will be connected with your applications, and then that will serve your purpose. So the third thing is, actually, then you need, at the current time, start to build your AI capability. This includes you need to get resource, you need to hire right talent, you need to have all the fundamental AI-related IT capability ready for your company. So I will start with this. Like Amazon, we started AI right from the beginning of our days. So in 1997, when Amazon.com is launched, we use recommendation, we use personalization for the e-commerce. And since then, we've been continuously using AI to enhance our business and create value, including Alexa, the voice service. So for machine learning, if you look at the technology related, it takes full stack of those technology. Roughly speaking, from the bottom layer, you need to have machine learning infrastructure in place. And then you need to have data, then you need to have a machine learning framework. And then on top of that, machine learning tools. And then at the top layer, machine learning applications. So for AWS, actually, we've been released a bunch of cloud services exactly matching those required machine learning tools and frameworks. So we have basically, bottom layer, the infrastructure, the chips, and we have data stack. We have SageMaker in the middle, and then we have Bedrock, and we have Amazon Q. So I'm going to spend the rest of the time give you some quick introduction about those services. I'm not trying to sell you those services, but it's really for purpose of learning. If we look forward, looking into the era of generative AI, what kind of service you need to have, what kind of capability you, as an enterprise, you need to build. And you can select our staff, or you can use partners, or friend companies. We can do all different type of stuff. So let's take a quick look at how AWS offers the core 3 layers for generative AI. From the bottom layer is the infrastructure. Cloud undoubtedly is still the most important way to offer you machine learning infrastructure for the storage, for the computing power. And for us, we have those in place, and we also do a few special things. One is actually we also offer some special chips. And at this COMPUTEX, we heard so many things about chips revolution. We see many good examples. But for Amazon, we continue to also work for specially customized chips for AI. So we have training and we have inference. So from the name, you can understand one is for the training purpose, one is for inference when you have the model. And then we are very happy that we've been working with our partner, NVIDIA, which is a superstar now. Jason and Lisa, both a superstar at the Expo. Also, our first speaker gave us some idea, how they are going to roll out new stuff in the coming years. But we are very happy to tell you, on the cloud, we are the first to introduce GPU into the cloud instance, starting from our CG1, and then we continue, for example, like P4, that's the A100, and P5 is H100. And then for the Blackwell architect, the new stuff, 200, B200, and so on, we have planned to roll out those very soon. So you can see, actually, sometimes if you want to get those chips and install on your server, it takes time. But very often, we can have those launched very soon, our cloud facility, so customer can use that. And then the other thing is a service, we call it SageMaker. That has been around for 6 or 7 years. That's a fully managed service helping a company to deploy machine learning models from the beginning to the end, taking care of selecting an instance, getting the data ready, training the model, and then implement the application, and at the end, infer and use the result. So this actually now in the new era of generative AI with all the foundation models, we actually still we can use this. You can build your own foundation model from the scratch, or you can connect with different type of ready-made foundation models. And you can also customize, fine-tuning, and continually pre-train your model. It's all possible, and it's also a service people use for foundation model operation. And so this is the first layer, bottom layer. Let's look at the middle layer. The middle layer, again, I already talked about, from the simple prompt engineer using Alice models to the fine-tuning, to the RAG, to the continuous pre-training. So there are many ways you can do. And as we go, we will see actually no one model will rule for all. So everybody now understand as a function of time, there will be many different foundation models show up. We saw that in the last couple of months, different foundation models competing with each other and very quickly. But as time goes, we will have more specially trained models for different industry, different subject area, and also multimodal is a big trend. So because of that, we offer this, we believe, a very important service called Amazon Bedrock. And this is actually our way to allow customers to take advantage of many commercial foundation models, as well as open source foundation models. And then you can put your data in a safe, secure, private area, and you can leverage those. So some of the fundamental things, it allows for model customization. It allows you to connect to agents. You can also, build API, you build applications connecting with API. So very simply, Bedrocks help you to have a choice to choose different foundation models, to customize them, and to integrate them in your working production environment in a safe and secure way. So actually, by now, over 10,000 customers worldwide used Amazon Bedrock. And here I want to say, actually, in Taiwan, Zhonghua Telecom is one of the company actually tried Bedrock. And if you go to our website, you can see the quote from their VP talking about their experience. And here I give you another 2 examples. One is Adidas. Adidas actually, they used this and gave the community of Adidas engineer interface. They can use that to organize their internal information resource and form something like a ChatGPT type of thing, but their own company-owned version. And the other company is a Carrier, global refrigeration company, and they use it actually to look into the process of the customer information, helping to lower utility bills and also trying to maintain better sustainability. So Amazon Bedrock actually currently will be able to let you to select different foundation models, and including some very advanced foundation models like Anthropic Cloud 3, like Meta Llama 3, and Mistral Stability AI, and including our own stuff. So for Anthropic, you probably heard, Amazon invested $4 billion in the company, and we worked with them, and we provided the Bedrock in 3 different sizes for speed and for price. And so we have different level from the lower end of Haiku that provide a quick, very efficient way to give you fundamental results, to something more fancy, Opus, and I give you a lot more intelligence and high-risk performance, and also Sonnet in between. And on the cloud, you can quickly start to use this on AWS cloud. And I suggest any of you give it a try. I did some very simple thing. I just asked, for example, like, can you tell me if you are AWS managing director for Hong Kong and Taiwan, what kind of strategy you would have for the year? We were often surprised by the solution, and some colleagues joking, oh, this seems even more comprehensive than what our leaders said in our annual kickoff meeting at the beginning of the year. So give it a try. And also recently, Meta announced the Llama 3, and it's being rolled out by us very soon. Of course, Amazon, we have our own model, foundation model too. It's called Titan, and we have different versions. We have the version that's test embedding, that's actually directly expose the vector embedding for the large language model to you, and also test light, test express, multimodal embedding, and image generator. That's the 5 models currently we are offering. And we are, of course, continually working on those to refine them, to polish them. So here you can see, actually, with this Bedrock, it provides you this capability. You can start with your data, and then you can select some foundation model of your choice. And eventually, some of the company, they customize the foundation model. They can also develop your own foundation model. And then you can use them for different ways and build, working with your data in a secured enterprise environments, not just through the data to the open internet. And many companies worried about who will be able to get access to your data and your information. So this way, you'll have the data in your own way. You'll fine-tune or continually train your model, and all those are in the closed environment of your own. So Bedrock, actually, we continue to offer more capability. One is the so-called agents for Bedrock, and that will give you the capability to do AI agents, which is a big thing everybody knows. Basically, it allows you to execute multi-steps tasks. That give you the opportunity to execute a series of different steps depending on the interaction with the user. And then in addition to that, we also have something called knowledge base built on Bedrock and guardrails for Bedrock. Guardrail actually give you a safety security layer, helping to guard both the input and output of your models. So you can easily set up some rules, what need to be blocked, what kind of a question, like a financial question, asking something to choose a particular stock. It may give you some suggestion, but it needs to come with a standard disclaimer, or some of the question, if it's not moral or it's illegal, it can help you to block those. So as a summary, this is currently the 3 layers we offer, and we believe from the enterprise point of view, AWS is really leading among all the cloud vendors. You heard it from everybody else. You can compare. And then, in the top layer, quickly, we also offer something called Amazon Q. It's an AI-powered assistant for your work. And that helps you to use your private company information to do an internal kind of a chatbot application. And you can use it also for content generation, video tests, many different models. But all in an interactive way, using your company information, personalized, secure, and safe. And this actually, Amazon Q, also have different versions already. It has specially tuned for general business or for just for IT and developer, and also it has for call center. It's called a Q in Connect, or for BI, data analytics, QuickSight, and also a version just for supply chain. And there are many different areas for business user, IT user, developer, special needs. You can use those. And you can imagine AWS will continue to refine and polish those as we listen to your customers' requirement. And here we have an example from QuickSight, using QuickSight from BMW. So they put their data, and then they run that in QuickSight, which is our AI graphic display capability. And then that's combined now with Amazon Q to give you that automated capability. OK, so let me summarize. So here I tell you from the 3 layers what we are working on. And just in about a month, we will have our New York Summit. We believe we will have some announcement. And later this year, of course, we will have our re:Invent near the end of November. That's our largest technology event. And we will have more service coming out. So as a summary, we can see we mentioned the 3 steps. Select the right use case, prepare your data foundation, and then actually you can start to build your capabilities and start to have generative AI working for your enterprise. And before I finish, give you some additional recommendation based on our engagements with worldwide customers. First, you want to keep your eye open. Generative AI is so new, and many things is going to change a lot. So have an open mind, have a flexibility to adopt, and keep curious, encourage all your employees to learn. And second thing, flexibility is the key. So you want to build some solid foundation while you want to maintain flexibility for foundation model selection, for some quickly change some tools if needed. And then we know no one size fits all. So you really need to explore what kind of foundation models will really work for you, and whether or not how much you want to do yourself, including some fine-tuning, including continued training. And for most of our companies, at the stage, we don't need to build our own foundation model from scratch, which takes a lot of time, a lot of money, a lot of resource. And then we also suggest you really start to act. So I have 5 simple steps as the last word to you. So you can select the right use case, empower your team, encourage them to learn, and get started on some top use case. And then move to production. Make it real. Make it a real impact to your business. And if it works, you want to scale them. Make it really work across your company. So that's all I have, and really my pleasure to share with you. And AWS, we have our team based in Taipei, and we are in the 100 building, and welcome you to contact AWS Taiwan for any requirements, any support. Our team will be very happy to work with you, to support you, to start the AI journey today. Thank you.
Thank you, Mr. Zhang, for the practical insights to unlock the transformative power of AI. We've had a stimulating morning session packed with thought-provoking presentations, but the conversation doesn't stop here. Join us in the afternoon session where we will explore what lies behind generative AI. Please remember your personal belongings as you leave the room. Thank you, and see you in the afternoon.
Innovation spark, illuminate digital nights. Yes, 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 yes. Tech titan startups, forging paths ahead. Let's go. At COMPUTEX core, where legends are bred, where legends are bred. Yo, check it, it's the rise of the tech scene. Listen close, AI's the heartbeat. Tech giants, they impose startups on the grind. Chasing their dreams in the realm of innovation.